Hello, y'all. Welcome to lesson 73 of my DB chemistry curriculum. Today we're going over reactivity 1.3.2. We're going to be talking about the incomplete combustion of organic compounds, especially hydrocarbons, leading to the production of carbon monoxide and carbon. We will deduce the equations for incomplete combustion of hydrocarbons and alcohols. This is going to be a relatively short video and a relatively short section because it doesn't have too much to it. So the first thing is with a normal hydrocarbon CXHYOZ, and we combust that, which means reacting with oxygen gas, we always get H2O plus CO2. Usually water is in the gaseous state. Sometimes it could be liquid, but these are the products of combustion. This is what we learned in the previous video. However, sometimes oxygen is limiting. So if O2 is limiting, then we get incomplete combustion. Now, that can be for a few reasons. Incomplete combustion can just be a general lack of oxygen. Sometimes it can also be, so this can either be a lack of O2, or it might be our fuel is reacting too fast. So it's like reacting before enough oxygen can replace the oxygen lost from the environment. So these can lead to incomplete combustion. A couple signs of incomplete combustion is generally when you have a flame. So we're going to do two candles. If you have, whoops, if you have perfect combustion, you actually tend to have a blue flame. I like to think of this as like if anyone's seen Avatar: The Last Airbender, Azula is so good at firebending that her flame is blue because she has complete combustion. She is so perfect at it. Meanwhile, the rest of the firebenders who aren't these prodigies tend to have red flame or orange flame. And usually that signifies that this is actually incomplete combustion. Furthermore, if we have the presence of smoke or red-orange flame, red-orange flame, these are incomplete. So this is generally what's going to tell us complete from incomplete. The reaction we learned up here, this is complete combustion. Perfect, complete combustion. If we have incomplete, we have two varieties. So we have limited oxygen environment versus very limited oxygen environment. Now, in a limited oxygen environment, our products change to carbon monoxide, also a gas, and we still get water. You'll notice that the lack of oxygen in our reactants leads to a lack of oxygen in our products, which makes sense, specifically in the carbon product. We went from CO2 to CO1, or carbon monoxide. From this, we can make a prediction that in a very limited environment, we're going to end up with just carbon plus H2O. This carbon's interesting because a lot of you may already have seen it before. This becomes aerosolized particulate. Aerosolized black gray particulate. In other words, that's just smoke. So when you see smoke, what you're seeing is carbon going straight into the air. And so this is pretty much all incomplete combustion is. That's the end of the section. The one thing we'll do is this works with anything. So if we look at propane, we can look at CH or C3H8 plus O2 reacts to form CO2 plus H2O. That's a standard reaction. When we look at propane in standard conditions, we can balance this. We'll just throw a big 4 right there, a big 3 right here, and then we have our sum of oxygens, which is 6 plus 4, that's 10, and we put a 5 right here. This changes, however, once we have incomplete combustion, so C3H8 plus less O2. And let's say we have somewhat complete combustion, somewhat complete, plus H2O. We would still normally put 4 here and 3 here, but we then have a little issue with our oxygens because we have 3 plus 4, which is 7. So I would generally just, instead of putting 7, I would put about 3.5 here and then double it all, which is just going to change, oops, oh, 2. So we're instead going to do 2, 7, 6, and 8. You'll notice the ratio from our carbon to our oxygen is a 1 to 5, or our carbon-containing compound. Well, now it's 2 to 7. So the amount of oxygen has decreased, and we're literally reacting less. We can go to one step further with C3H8 plus even far less O2 would produce just carbon plus H2O. Once again, we're going to put a 4, a 3, and now in this case, a 2. You'll notice the proportions decrease even further. It's now a 1 to 2 ratio versus a 2 to 7 and a 1 to 5. So the percent oxygen in the reactants is decreasing, which changes the way our reaction works. One final example is that we can also do this with alcohols, which are still hydrocarbons, propanol, which is the same thing. It's just C3H7OH. That OH right there is the alcohol. This could be isopropyl alcohol, for instance, plus, O2, reacts to form, and we'll do very incomplete combustion, carbon solid plus H2O. In this case, we would have to actually have 8 to 6 to 2 to 3. So once again, we have an incredibly limited oxygen environment here. So I hope this helps you understand a little bit about incomplete combustion that you can take with you in future exams. The keywords you want to look for are things like limited oxygen versus very limited oxygen, or somewhat incomplete versus very incomplete. So keep an eye out for those words as you're looking at combustion reactions, and have a great day.